Now we have our first video for unit number 2. This is section 1, graphing systems of equations. Some terminology to go over first. A system of equations is just two or more equations that have the same variables. So we might use something like y equals 2x plus 1. Well, we need another equation with y and x, so we might do y equals 3x minus 7. That would be a system of equations. It's just two or more equations that have the same variables we're using. Now, a solution for that system would be values for the variables that would make the equation true. That have to make both of the equations true at the same time. So you can see down here we have a graph of two lines, our red line and our blue line, and they intersect each other at one point right here. That would be the point 6, 2. Looking at our graph. So even though we don't necessarily know what these lines are, what those equations are, the solution for those two would be 6, 2. Or if we plug x is 6 and y is 2 into both of those equations, it would work in both cases. I'm going to move right along here with some more terminology. So on your notes, you'll see a concept summary, possible solutions. I want you to draw these kinds of graphs in that you see. In your first blank, have two lines kind of crisscrossing each other, so kind of like this here. And you can see that they intersect each other at a point somewhere around there. Draw another graph over here of two parallel lines, and if you want to write down, like I have up here, that they are parallel, that might be helpful. And over here, draw two lines that are right on top of each other. So I'm going to draw one that's blue and one that's red, and they're literally exactly on top of each other. It's like I'm drawing the same line in the same place. Okay? In each of these cases, you've drawn a system of equations. So in our first one, we have two lines, and we can see that they actually intersect each other. So we would say in that case that, oops, move that down, there's one solution to that. There's only one intersection. There's only one point where both of those lines have the same values. Okay, so only one spot where we have the same x value and the same y value for both of those equations. Now, if we have parallel lines, there's going to be no spots where they're the same. There are no solutions when you have a system of equations that are parallel. You'll never have any points be the same. Now, if you have two equations that are giving you the same line and you try to graph them, then technically every single point is going to be the same between the two of them. So there's an infinite amount of solutions. All of the points are the same on those two lines. So one solution when they intersect, no solutions when they're parallel, and all of them are solutions when it's the same exact line. So what would be kind of a description of the equations or something you would see with each of these? Well, again, if we have those two intersecting lines, so you look at those equations and you notice that they have different slopes and different y-intercepts. Okay? Each one's going to intercept the y-axis at a different spot, and they're going to have different slopes as they're going. They might be perpendicular, they might be very, very close to the same thing, but if they are going to intersect, the slopes have to be different. Now with parallel lines, they're going to have the same slope and different y-intercepts. Okay, so we can kind of see up here, they're both going up and over at the same rate, but this one has a y-intercept down here, and this one has a y-intercept up here. So they're different spots where they're hitting the y-axis, but they're still changing at the same rate. And if we look at our same ones, the same lines, these ones are going to have the same slope and the same y-intercept because, of course, they are the same exact line. They have to be the same exact thing. Maybe it's said two different ways, two slightly different looking equations, but if you can kind of manipulate them and move things around to make it look like the exact same equation, it'll be the exact same line. Now a little more of our terminology. If we look at consistent, a consistent system would be a system that has at least one solution. So it intersects at one point or it is the same line. So This one, oops, let me grab my box here. Not moving the whole thing. That's fine. Consistent is our first one. That one is a consistent system. As well, this one over here, when it's the same exact line, that is also a consistent system. Okay? There's going to have at least one solution. There might be infinite, but at least one. An inconsistent system is one that would have no solution. The only way to have that is when we have our parallel lines. So that would be an inconsistent system.